Okay, we're in the section now where you need to start thinking about, did you understand what was presented to you? So, I'll do one at the whiteboard, I'll do two at the whiteboard, and two has a little code there. We'll talk about that as well. And for three, what I'll do is I'll actually go to, walking through it with you, but it's going to be a coding exercise. By the way, I'm not suggesting you're at this stage of coding, but certainly you're at the stage where you can read and try to appreciate what's being presented to you. It does take time and it does take effort. So what I want to do is start off slow, and I'm going to go to the whiteboard and try to do number one for you. All right, give me 1 second to do so. Okay, so the first thing up, it says, show the sum of the first n positive odd integers is equal to n squared. So let me just, talk about that, what would that look like to me? And just take a little case first. So maybe like 1, and let's see, sum of the first n positive. Let's say, well, next odd number would be 3, right? And next odd would be 5. I certainly know how odd integers behave. What are they claiming? Well, this would be equal, there's 3 terms there, would be equal to 3 squared. What's that together? 1 plus 3 is 4. 4 plus 5 is 9. And 3 squared is certainly, that's true. Let's try another one. 1 plus 3 plus 5 plus 7. What should that equal? 4 squared. Let's see what we get up there. Well, clearly 16 equals 16. It seems reasonable to me. Now, by the way, I'd hate to be doing this, number after number. I need to get some kind of general statement going. All right. So let me get my eraser out. And I'm pretty convinced what they said is true for, the first 3 and the first 4, but I don't want to keep doing that. I want to come up with a general statement. Well, let's go through that. And I'll write this one over here. And let's see, we have 1 plus 3 plus 5 plus yada, yada, yada. Now, I know a lot of people want to put n there, and I'm not saying that's a bad idea. I don't think that's what they said. So what's this over here? This is A1. This is A2. And this is A3. I want to know what AN is, though, what the nth term is. And they claim this would equal n squared now. All right. So then the deal becomes, what would that be? Well, I think if you look at these things over here, and again, what I mean by looking at these things, this goes back to the sequence and series that we were doing. This is going up by 2, right? So let's write this down, see if it's true. I'm going to write down, let's see, something to do with 2n, right? So 2n, something to do with 2n. Now someone says, why is that? They're going up by 2, right? So A1 is 1, A2 is 3, A3 is 5. And I'm saying that's something to do with 2n. So to me, it looks like it might be 2n. I'll check it though, minus 1. Right? It looks like that. Now, when I say that, what's the n going to be? Well, the n would have to be 1 then, right? So let me get my eraser out and see if this is true. I'll write that down for you. Times 1. What would this one be? 2 times 2. And again, I'm thinking it's 2n minus 1. Well, that's 3. That's true. What's going to be 2 times 3 minus 1? And that's true. So I'm going to say the nth term is 2n minus 1. All right, let me erase. And again, we have to have a background together here. And that is, did we do all the required material before we got to the appendix? All right, so I think I'm ready to write my sum down now. And let me go for that. Pull this over here. And let me write this down. I'm going to write a summation formula down now. And yeah, we've done sums before in this class. So the sum, whoops. Let's see, the term is what? It's going to be 2n minus 1. And we're starting at, I'm going to use a different counter. I'm not going to use n because I want to stop at n, right? So let me erase this over here. I don't want to put n there. I want to put k. And k starts at 1 and it stops at n. All right, so if you did that, you'd get the first term, put 1 there, you get 2 minus 1 is 1. That would be 4 minus 1, which is 3. And then what do you get there? Let's just check it. That would be 4 minus, I'm sorry, that would be 3. So 2 times 3 is 6, 6 minus 1 is 5. And we get to the last one will be 2n minus 1. And again, they're claiming that equals n squared. So let's keep going. Again, we did sums before. So what does this thing divide into? Two terms. It's 2k. K equals 1 to n minus k equals 1 to n of 1. And again, they claim it's n squared. I don't know. Maybe they claim that's the claim's not true. So this is going to be 2 sum k equals 1 to n k minus the sum k equals 1 to n 1 n squared. Well, I certainly know the first guy, and it's going to be 2 times n, some of the integers, by the way, n plus 1 over 2 minus, now the x guy is going to be 1 plus 1 plus 1 plus 1. There's going to be n of those, so n times 1. And again, their claim is equal to n squared. Let's go through it. This cancels off. And what he left off with? N squared plus n minus n, and that certainly equals n squared. Why is that? They cancel off. So we just do what they're supposed to do, and we got that done. So we're over here. This is done. All right. Now, granted, I know it's tough. You may not be able to remember these things. And I'm saying the point is you don't really need to remember everything. You could always look things up, but I would like to, be able to go through this in such a way that I could come up with this sum over here. And so I'm going to go through it with you, and I'll write it down for you. So I'm going to do number 2, and I'll write this down for you. And again, what I would do is simplify this, the thing, the sum here. Let's see if I can do that. So it's the sum, n equals 1 to 10. This would be n plus n squared plus n cubed. Well, this is going to be the sum, n equals 1 to 10, n plus the sum, n equals 1 to 10, n squared. All things that we've learned in the past, by the way, about summations, n equals 1 to 10 of n cubed. Now, do I know what those sums are? I do. For example, the first guy is 1 plus 2 plus 3 plus 4, and that's pretty simple. What's that going to give me? Well, that's going to give me what? Let me just make sure they said 10 over here. Yeah, they did. All right, let's keep going. What do you get over here? You would get n, 10. 10 plus 1 is 11 over 2 plus, I'll leave the little guy for later. The second guy, a third guy is really easy, just the first guy squared. All right, and then what do you get over here? Well, I think I can remember it. Let me put this down for you. Kind of remember 6 in the bottom, right? And that's going to be n, which is 10. And then 10 plus 1 is 11. And then I get 2 times n, which is 20 plus 1, so it's 21. Let's go through the arithmetic. 2 goes in at 5, so that's 55. All right, middle guy, I'm going to save for later. This guy over here is 55. Whoops. Squared. I'll do that later. What do you get here? Well, I'm going to try to do it. I'm going to say 3 goes into 6 2 times. 7. And 2 goes into 5. And let's see, you get 35 times 11, right? Which is 350. And 35, which is 385. All right, let me keep going to the arithmetic for you. And I'll put this down next for you. Let's see, 55 and 385. Oh, you know what I'm going to do instead? I'll do this instead. 55. I'm looking at this term and this term. 1 plus 55 plus 385. Again, the way we do arithmetic really doesn't much matter. It's what does matter is we can do arithmetic. You get 55 times 56 plus 385. Oh boy, I got to do some arithmetic here, right? So 55 times 56. And let's see if we can do that. And 6 times 5 is 30. 33. 25. 25, 27, right? 0, 8, 3080. Plus 385. Let's see if we can do that. All right, so 385 added to 3080. And you get 5, 8 and 8, 16, 4, 3, 4. Not so bad. All right. Now, certainly, I want to point out that we did that. I think we did that. We did this over here. Now, if I go to the next page, I think what they did was they got a general formula for it. All right. Let me just go through that with you. And again, I probably have to revise the notes a little bit, but I think we did this, and then we did this. Just putting the formulas down for you. Did some arithmetic over there, and it gets up here. What do I notice for a lot of students, though? Algebra tends to be tough. All right. So what I'm going to claim over here is I want to switch. I want to see if I can actually do this thing using the Sage stuff. All right. So let me switch back. And I'm going to go back to sharing this thing over here. I'm going to go to my terminal. I got Sage running. I'm going to type the code in, reset, and we'll check our the first thing I want to do is I'm going to, I want to see if I can do the sum. And I'll put this down for you, sum. I want to check my work, and I have it written down. That's what's good. I got the sum. What was I doing? I was doing the sum of, I got to define a variable here. So let me put this down for you. So n equals var. And I'm going to do sum. I'm just checking my arithmetic, by the way. And what are we doing? I guess we were doing, n star. Let me go back to that original statement, but I'll scroll up here. N star 1 plus n squared. All right, comma n, comma 1 up to 10. All right, let's see what happens. 3,465. I'm going to look back over my notes here and see if I wrote that down. Yeah, I got the same answer, a miracle. So what I want to do is I want to start to look at this code over here, and I'm noticing they got a general formula, and they got this formula over here for it. All right. What I want to do is I want to do a Sage code. All right. So let me clear again. Whoops, I didn't type in clear, did I? And I'm going to do reset. Again, I'm trying to learn a little bit at a time. And nk. And nk is a variable. N and k. By the way, there's a shorthand for this. I'm just going to put that in for you. And I'm defining n and k as variables now. And then sum. I'll write this down for you. SUM. And what do you get over there? K star. Whoops. 1 plus k plus k. Whoops. K squared. And close it out. And the counter variable is k. And we're starting at 1 and we're going to n. And did I type that incorrect? I think so. Good, we got that. Now what it says, it kind of looks crazy, not what I was kind of expecting to see. And I'm gonna, because what I was expecting when I did my hand arithmetic, not hand arithmetic, the hand algebra, I got this over here and I really can't see that as being the same. So what I do is I wanna do that again, but now what I'm gonna do is I'm gonna say factor it. Sage is pretty good at factoring. And what does it give me? Let me see if it gives the same answer. It gives me 1/12 star 3n squared plus 7n plus 8. I see that. Star n plus 1 not divide by times n. So I got the same thing. Now what I'm going to do is I'm going to define a function now, f of n, and I'm going to say that's equal to, and I'm just going to do a copy paste now. I want to see f10. That's all my handwork if I get the same thing. And what I get the same number, 3465, which is good news. All right, I'm going to clear the screen. And what I want to do is I want to read. I want to read this thing over here. All right, now again, my intent here is not to read to you, but a lot of times what I really mean by a lot of students, they really, the information they're getting is not from reading, it's from someone reading to them. Now what I mean by that, a lot of your professors are actually reading to you what they're doing. And this is a very unproductive way to learn. really what your education should be is that, you should be working problems on your own, but you need to start to study. You need to start to read and pay attention to what you're reading, paper and pencil in hand all the time, by the way. So I'm going to claim over here is, you kind of reading through this, and I'm going to go back to the whiteboard, by the way. And let me do that. And I'll go back to my whiteboard, and I'll pretend I'm reading and reading in front of you. Give me 1 second here. And I'm going to go to the next page here. And what I'm going to claim over here is, if this were me reading these notes, what I'd be doing says, if you're paying attention, well, I am paying attention, or paying attention myself, certainly. And I've been using paper and pencil. I hope you realize that. I don't write these notes without paper and pencil in hand, by the way. And I'm going to say that, also I follow throughout the course. I remember the summations. I remember all things. I can't say I remember all things. A lot of things I do forget, but I do remember presenting the course to you, and I got some local memory here. So what I want to do is I want to start, if there's for me reading this over here, I would pay careful attention to what's written down, right? So the first thing I want to make sure you understand is writing down is that I'm just reading it. I think we've covered this before. And I understand, that the SP was, the summation of the integers 1 + 2 + 3 raised to the pth power, where p was one integer and m was an integer. And I think we did this in the past, right? We've done this. You remember back over notes, we've done this. And we've done this one, we've done this one, we've done this one, and we've done this one. Now, what I want to claim over here is that I'm hoping you have a recollection that these have something to do with binomial coefficients. But let me write that down for you. Pascal's triangle. And I think we've done this before, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is me thinking, by the way. Again, we're trying to get you guys to think. And I guess I could keep doing this. I don't like Pascal's triangle, though. 6, 15, 20, 15, 6, and 1. And what do I start to notice? And I'm going to underline it for you. I'm kind of looking, again, when I'm looking at these things over here. I want to point out what I'm looking at. And I'm going to go over here and point out what I'm looking at. The next one's 5, 10, 10, 5. And then I got 6, 15, 20, 15. Oh, good. That's not bad. All right. So I definitely see that. Now, what else do I see in these problems over here? Yeah, I see these things over here. So what I'm going to claim over here is that it would be nice if I could write this down a little bit differently. And by differently, what I'm talking about is generalizing it. So my goal over here is to look at this and to generalize it, to go in that direction there, if I can do it. Sometimes I can't. I'm seeing something I can't generalize it. But what I'm going to claim over here is that I'm looking at this, I'm looking at this, I'm looking at this, and I want to see if I can write a general statement down, which is always tough for me. I'll be honest with you, never easy. It's never easy. All right. So what I want to claim over here is that what I do notice is, something about, the coefficients here. And I want to point down what these coefficients are. And I'll put this down for you. So for example, this one over here, if I looked at it, well, maybe I should go through that with you. Degree 0, degree 1, degree 2, degree 3, degree 4, degree 5, degree 6. So this would be, 6. And again, if you're counting in, you might go, 0, 1. And what would this one over here be? And this from past, this would be 6, 2. What would this one over here be? 6, 3. What would this one over here be? 6, 4. What would this one over here be? 6, 5. I think you have, if you have any past recollection doing the binomial theorem, I hope you have that recollection there. So I'm looking at it and I'm seeing it. And what I'm starting to realize is that, I could probably write that down, right? So I'm seeing, and I'll put down what I'm seeing over here. I'm seeing those coefficients. And these are the let me blow this up a little bit. I'm seeing this thing over here. Let me point out what I'm looking at. I'm looking at the power here. And then I'm seeing these coefficients over here. All right, I'm seeing them. I'm hoping you're seeing them too. So if I did this one over here, again, I'm going to point this out to you. This coefficient 6.1. When I say 6.1, the binomial coefficient, 6.2, 6.3, 6.4, 6.5. Well, I'm going to do this over here, 6, but now it's p plus 1. So what do I know? It's definitely p plus 1. Whoops, I need to do that. And then, p plus 1. And I got dot, 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 because it's going to go on for some time. And then what I got? Well, remember, 1, 2, 3. Let me repeat what we did up here. Remember, 6.1, 6.2, 6.3, right? I'm sorry, 6.1, 6.2, 6.3, 6.4, 6.5. All right. So someone says, what are you going to? One less than this. Well, if I'm at P, what's one less than this? It would be P. So what am I doing? 1, 2, 3, but going to P. All right, let's talk about the next thing I'm looking at, which is this thing over here. A nice orderly pattern. All right. So what should I see? It's going to be, if I'm starting at 6, right, it goes down 1 to S5. Well, if I'm starting at P plus 1, it goes down 1 to SP, then SP minus 1, SP minus 2, all the way down to S1. What's left in the end of it? Just the n plus 1. So what do? I kind of move things around. I want to point out what I'm moving around over here. Now I'm going to circle what I'm moving around. I'm seeing this, and I'm seeing this, and I'm putting them together right over here. And then what do? I write this business down over here as a summation. And let's go through that. So I wrote this here. I'm writing down as a summation here. Let's see if we can do that. Well, clearly, where do I start with? Start at 2 and end at P. Let me outline that for you. I'm starting at 2 and I'm ending at P. Starting at 2, ending at P. What are the binomial coefficients? They're always P plus 1 on top. And then the K goes from 2 up to P. That's pretty good. What's the next thing? This is going to be tough. You need to look at this, and I want to check it out. So if I start at 2, what would I get? Let me write this down. If I start at 2, what would I get? I would get S, right, P minus 2 plus 1, which would be S, P minus 1. Well, that's right over here. Let me see if I go to the end, which is P. What would I get? S, P minus P plus 1. Well, that would give me SP. Do I stop? I'm sorry. S1, I'm sorry. Do I stop there? Of course I do. So this sum looks good. All right. Now, keep this in mind. We've got to turn the page. All right. What am I expecting to see when I turn the page? I'm expecting to continue with this. Let me copy it. And I'm going to the next page. Paste that down here. All right. So I'm expecting this is the tough part. I am expecting that what you can do, right? What you can do. Let me make sure I did the right thing over here, because sometimes I say something. And, maybe I should go through this with you. I realize that maybe it's too much of a jump in reasoning. So I'm going to solve this thing for SP. P plus 1 over 1. Let me write this down for you. I'm going to put this over here. So this would be P plus 1 factorial. The bottom would be 1 factorial, p plus 1 minus 1 factorial. And if you did this, you'd just get p plus 1. All right, if you did that, you get p plus 1. Not so bad. All right, so I'm going to write this over here. So this would be p plus 1 times sp plus, oh, you know what? I'm going to write this. I'm going to maybe, I guess I got to push this to the side here. Maybe I went too fast there. And I got to pull this thing. You know what? I'm going to rewrite. I'm going to get my eraser out because I don't want to go with the other thing. And let's just talk about that. So n plus 1 to the p plus 1. And again, I'm looking at this. Is p plus 1 times sp plus n plus 1 plus the sum k equals 2 to p plus 1 k. Whoops, I always do that too. I shouldn't do that because that's a different meaning when I do that. And then s p minus k plus 1. It's not easy. I'm not saying it's going to be easy for you. So what do? I want to solve for sp. N plus 1, p plus 1, minus n, minus 1, minus the sum, p plus 1, k equals 2 to p, s, p minus k plus 1 equals sp. I'm going to divide both sides by the coefficient, which is p plus 1. So what I want to do is I want to start writing things down now. I want to write down S1. All right, so what's that going to be? N plus 1, well, P is 1, right? So it's going to be 2 minus N minus 1 minus, let's see if we can do that. Well, you know what? We can't. And I'll tell you why we can't. Because we can't do that second sum. We can't start there. We need to know what S1 is. So let's write that down. I need to know what S1 is to start this. This is what's known as a recursively defined function. If you notice this over here, this is defined in terms of itself. So if I don't know some kind of seed value, I couldn't go to S2. So let me write down S1. I think I can remember that, right? Erase this over here. And what would that be? That's going to be n plus 1 over 2. Well, let's write down S2, see if we can do that. And again, we're looking at this over here, what the P is. Well, the P would be 2. So what do you get over here? N plus 1 cubed minus N minus 1 minus, remember, P is 2, right? So we're going to start at 2. And we're going to stop at 2. What do we get here? This should be 3k s. Well, it's going to be p, which is 2 minus k plus 1. So it's 3 minus k, right? Over what's p again? P is 2 over 3, right? It's tough. I'm not saying it's easy. So what's S2? N plus 1 cubed minus n minus 1 minus, well, this is easy. It's a sum from 2 to 2. So it's going to be 3, 2. And let's see, that would be S1. That was easy, over 3. And you keep moving. What's S2? Well, it's n plus 1 cubed minus n minus 1. What's 3, 2? It's just 3. Right? It was 3 factorial, 2 factorial, 1 factorial is 3. N plus 1 over 2. That's what S1 is, and over 3. All right, what am I going to do now? It's not easy. I'm not saying it's going to be easy for you. I'm going to multiply the top and the bottom by 2. And what's S2 going to be? 2 times 3 on bottom is 6. That's easy. Then you get n plus 1 cubed times 2 minus 2n minus 2. minus 3n n plus 1. Oh, this looks tough. Let's keep going. 2n plus 1 cubed minus 2n plus 1 minus 3n n plus 1 over 6. I'm going to factor it. This is hard work, though. I'm going to say n plus 1 factors out, right? And what do you get? 2n plus 1 squared minus 2 minus 3n over 6. Oh, it's a lot of work. N plus 1. Well, this is going to be 2n squared. Let's see, 2n, 4n plus 2 minus 3n over 6. What do you have here? N plus 1, 2n squared. Let's see, 4n minus 3n is plus n, right? And the 2's cancel out over 6. It's never going to end, right? It does end. What do you get over here? N plus 1, 2n plus 1 over 6. And what's this thing over here? S2. Okay, let's go to the next page. And I want to point out, whoops, I got to get to the next page here. I think I got S1, and I think I just did S2 for you. And I think I did this for you. Okay, what do I notice? Again, the algebra, tough. So what do I want to do? I want to use Sage. All right, I want to remind you though, and some people think that I'm an expert in Sage. I am not. I rarely use the product. All right, now someone says, why do you promote it then? Well, I'm at the end of my career. You're at the beginning of your career. You need to learn to use a computer algebra system. All right, so let me read this to you. I would say I try to create a recursive function. So someone says, what do you mean recursive? I want to go back over here and point out to you over here that this over here is a recursively defined function. It's recursive. What do I mean by that? It's defined in terms of itself, but I need a seed value. That's the seed value for it. So what I did was I tried to program this into Sage. I actually did it. Let's go through that. So, I tried to create a recursive function using Sage. I definitely did. I had trouble. So I posted the following to Sage's ask your question. This is what I posted. It says, I'm trying to, get a recursive function for this. I'll show you what this is in the notes, by the way, and appear positive integers. My Sage code correctly returns S1. Well, no kidding. That would be hard not to return that, but it didn't work for P greater than 2. And then I asked them any ideas. All right. So what I did was I posted my code. Here's my code. By the way, my code has trouble. I kept looking at it and I just could not see the trouble. I couldn't see it. I could not see the trouble. So that's why I went to Sage. I don't often do it because I'll be honest with you, if you keep going to Sage asking like IK stupid questions over and over again, you're going to get labeled as someone who asks stupid questions over and over again, right? You don't want that to happen to you, right? Make sure that when you're posting a question that you've given it, so a considerable amount of thought before you got through that. All right, let me go to the next page. And I want to point out this is what my posting looks like on Sage. All right. My name's up there, Bannon. It's the same question, put my quote down over there. And then what I hope for, I hope I get someone to respond to me. Well, almost immediately someone does respond to me. All right. So this guy over here responds to me almost immediately. I mean, like as soon as I post it, I get an answer right away. Unfortunately, he didn't give me the answer I wanted. He gave me an answer just using a built-in function for Sage, which is the sum function. I'm not opposed to it. It does give the correct answer, but it's not what I was looking for. I was looking to code my recursive function, and it just wasn't done there. But this does work. This works. This guy here gave me code that works. He thought I just wanted code that works, but that was not my intent. My intent was to learn Sage to see if I could write a recursive function in Sage. All right. So what I did was I waited. And I waited for someone else to respond. Now, I'll be honest with you. If you go back to Sage now and look for my question, a large number of people read it, but not a large number of people respond. But this is the second guy to respond to me. And I'm glad this guy responded to me. So this guy responded to me. Whoops, I did it again. This guy responds it. And what does he respond to me? With the more informative posting that addressed my troublesome code issues. He took the time to explain what was wrong with my code, and he provided edited version of my code. Let me go to that. Now I'll go to that thing over here. So I'm going to put over here is that this is this guy's response, right? This is his name over here. He responded to me. He told me what was wrong. And I'm glad he did that. And he actually typed in new code for me. I'm glad he did that. All right. He told me what was wrong. And he gave me some hints. What did I do? I thanked him. Which is what you should be doing when someone answers your question. All right. Now, I want to warn you about this group over here. If they think that you're asking a homework question and you've done little to no work in your studies, they're not going to answer you. This is so typical. So what I'm going to claim over here is, I did my work. He looked at my code. He knew what was wrong. So what I did was I basically recoded. All right. So what we'd like you to do, and I suggest you rewrite both the code that this guy gave me and the other guy gave me and see if the results are the same. So I recoded it in. We suggest you do that in the next page. And I did it. And what I did, I recoded it. And what I mean by that, I used a lowercase s here for the first guy, and I kept the s, the big guy over there for the big guy over there. But I did it. And what I noticed was that the recursive function I wrote, I timed them, by the way, is really bad. Right? It doesn't compare nicely to the built-in Sage. But you certainly, I'm going to recommend you read through my answer over here. All right. I also recommend you put in the recoding of it. All right. Remember, things that are in blue, what does that represent to me? Work of a solution that you should work forward to. I think it's great if you could read through this over here and try to make sense out of it. It's tough though. All right. If you need help in coding though, all right, I'm not a coder, but I could look at the code that I presented to you or the guy that presented over here, and I can help you with that, including if you're having trouble retyping my code into Sage. How do you do that? Come by during office hours and we'll discuss that. Thank you.